So I've been involved with instrumentation for the SALT telescope, in particular building a subsystem of the Robert Stobie prime focus spectrograph on the telescope. This spectrograph has many different modes, some of them unique on large telescopes, and the instrument that I've built is an imaging spectrophotometer involving a Fabry-Perot interferometer that allows you to measure the spectroscopic information over the entire field of view of the telescope simultaneously. So it's very efficient for gathering two-dimensional spectroscopic information. For example, rotation curves in galaxies, emission line distributions across nebulae, or stellar absorption lines in a cluster of stars where you can measure tens of thousands of stars simultaneously. So it allows SALT to be highly efficient in getting that sort of data, something that few, if any, other large telescopes can do. In addition, the Fabry-Perot imaging spectroscopy can be combined with the other modes of that instrument, particularly the polarimetric modes, to allow you to get something that no other telescope, let alone large telescope in the world, can do, and that is polarimetric Fabry-Perot imaging spectroscopy, something that I think even I'm scared to think about. Then I've used this instrument to pursue my scientific interests, which are primarily the dynamics of other galaxies, measuring the rotation curves of galaxies, the motions of stars and gas within those galaxies, and using them to derive dynamically the distribution of matter, both luminous and dark matter in the galaxies, which gives us some insights into the processes by which those galaxies formed cosmologically and how the dark matter and the luminous matter interplayed through the formation history of the galaxies.
So I did my master's research on the analysis of SALT Fabry-Perot medium resolution data. And the major goal of this study was to derive three rotation curves of three late-type spiral galaxies. And these galaxies are part of the 30 galaxies of the Mongoose sample. And the Mongoose is a H1 survey. And from that studies, we use these two different software packages to derive the rotation curves. And the goal was to be able to compare the kinematic parameters that we will get from out of these two packages and check the goodness of these fits. And I think these three galaxies are the ancillary, it's kind of ancillary studies of these 30 galaxies of the Mongoose. So we aim to observe all the 30 galaxies with SALT for further studies for the PhD.